If I want writing algebra equations with addition and subtraction, I can write algebra equations with addition and subtraction.
Thank you, Leanne. Do you guys think you're capable of writing algebraic equations with addition and subtraction?
Yes.
We just did that. You feel better about it now?
Yes.
Cool. Let's talk about what we did, okay? First of all, we defined some words. Sum and difference, I'm going to skip over them because I think you guys are pretty good at those. An equation always has what, you guys?
An equal sign.
See, I need everybody though. An equation always has a what?
Equal sign.
Good. So there's always like two sides. One side is equal to the other side. They're the same. Okay, a variable, we are pretty good at that one. The break apart problem is the tricky one, I think. A break apart problem is a drawing that shows a, what's this word?
Relationship.
A relationship between addition and subtraction. So we're going to talk a little bit about relationship when we go into our next section. Okay? So a break apart problem. This is a break apart problem. Yes, no?
Yes.
Okay, we have taken this number 5 and we put it at the top of what looks like a little mountain, right?
Yeah.
And then we gave you x and 3. And you needed to take those numbers and variables and break them apart. And you needed to write equations, right? Equations that showed, what's the R word that we just talked about? Relationships between all 3 of those numbers, right? So would you say it's fair to say that this number 3 and this number x, when you combine them together, you get 5?
Yes.
Is that a relationship between 3x and 5?
Yes.
Excellent. Would you say that if you take this number 5 and you subtract something x, we don't know what it is, it would be 3?
Yes.
Again, are those a relationship between those numbers?
Yes.
Holy cow, good job. Okay, we did number 7 in the same way. But instead of using whole numbers or integers, we use decimals. And it's okay, it's totally okay to say that this number is 0.65, right?
No.
Can you say 0.65?
No.
What must you say on the count of 3? 1, 2, 3.
6,500.
Good, and I'm not going to go through. It's the same thing that we just did for number 6. And number 8 is the same thing as well, except for we have a mixed number that we converted into an improper fraction. And again, just showing the relationship between all 3 of those numbers on that break apart problem. Yes, no?
Yes.
Cool. And then number 3, we did an actual real life problem, which we try to do in every single lesson. We were talking about the distance from 6th grade to 5th grade. You guys created your own break apart problem here. I didn't give it to you, right? The other ones I gave it to you, you had to write the equation. And you guys were able to do this from all of that information right there. 256 represents what? Anybody? Somebody raise your hand. Yes, ma'am.
The number of steps from 6th grade to 5th.
The number of steps from 6th grade to 5th grade. 102 represents what, ma'am?
The number of steps
From the 6th grade front door to the,
cafeteria.
and were they Tory steps or Abby steps? They're Tory steps, because it says in the word problem. Now, x, what is x? It's a variable, but what does it represent?
It represents the steps from the cafeteria to 5th grade.
Do you guys remember how hard it was for us to come up with what x represented? Remember how many of you raised your hand and I said no. Do you understand why it's really important to know what that x represents?
Yes.
Cool. And then again, we just did a break apart problem. We wrote a whole bunch of equations and you guys were all good. Questions? Yes, ma'am.
So the whole point of